now have with us Dr. V. Sandeep. I think this is the last presentation of this session. Dr. V. Sandeep, he is the principal investigator and project coordinator for the CRTDH at NIT Andhra Pradesh. This is also I think Dr. Sandeep hasn't come. In his place, Dr. Shankar will make the presentation. And this is also a very new CRTDH, just came up within like in the last 1.5 years. So it would be interesting to hear from him what they have done in the CRTDH.
Good afternoon. Myself, Shankar. I'm one of the program manager along with Dr. V. Sandeep. He's also a program manager. First of all, I would like to acknowledge the DSIR for giving and believing us this CRTDH laboratory to NIT Andhra Pradesh. Though our institute is very, like it's a young institute, it's the 31st young institute belongs to NIT area. So our major area of this CRTDH is electronics and renewables. I would like to thank the dignitaries of the DSIR CRTDH, Dr. Sujata Chaklanobis, as well as Vipun and Dr. Kailash Patekar. So let me begin the activities of NIT Andhra Pradesh CRTDH. So okay, the main objectives of this CRTDH is first we try to motivate the students and the faculty to interact with the industry demanded or industry oriented research problems in the areas of renewable energy for supporting MSCs. Then we also intended to support MSCs in the ideation and evolution, design and development and testing process in the areas of renewable energy. And then so we would like to extend our services in starting of new startups as well as like especially in mentoring in the areas of renewable sector. Then so we would like to help like adapting technologies like Internet of Things and edge computing and AI driven research models for betterment of MSC's production as process model. Then we would like to, the last objective is to improve the skill sets of MSCs towards application of the knowledge in the manufacturing process and products. Coming to the specific areas, before that when it comes to the renewables as well as electronics, the major part of like renewables, if you see solar as well as the wind, they are more volatile in nature. So the penetration of the like wind, more wind and more solar, so has issues like stability concerns. So our idea is to look into that stability concerns. That is one area. And then the second, the major challenge is like the power electronics, what the major parts of the converters, otherwise they are the major part of the components in renewable systems. It could be wind power generation or it could be solar power generation. They are more volatile actually, they are more the fault prone actually. So it is important to improve the reliability. So our intention is to improve the reliability concern is the major areas of this CRTDH. And one more is like intelligent control, like these days like AI as well as like edge computing. So there are some state of art technologies, like we help MSCs to adopt the state of art technologies. Then we also do the testing, analyzing, characterizing of the components related to the renewable systems. And more importantly, we are also aiming to create some repository of like repository in the areas of renewables, like few have completed. So one we completed is the grid integration aspect. So that is made available to the MSCs so that they can immediately take the technology and then they can use it. So this is a cluster actually. The center was at Tadepalligudam. It is connected between the Vizag and Chennai. Actually, there was industrial corridor, the Vizag and Chennai, and we was more connected to West Godavari, Eluru, Bhimavaram, Tanuku, and Palakulu districts of Andhra Pradesh. and of course our area falls under the electronics and renewables. So if you go through that, the major parts of this CRTDH, it was divided into four. One is research and technology transfer, other is testing and consultancy, other is skill development, other is incubation. So as I told, like we was into the renewable energy systems, we want to include some IoT and digital twinning and machine learning in the grid integrated systems, as well as reliability is one major concern. We want to address that. So coming to testing and consultancy, like we was giving like the equipments was available for visual inspection as well as earth continuity test. Then the battery testing, then renewable component testing, and then so we have some testing equipment for finding the efficiency of the converter, the total harmonic distortion, then the fault tolerance. So this is some state-of-art facility available at DSIR till now. One is microgrid setup. If somebody interested in developing some control algorithms, they can come here and then the test the control algorithms. Similarly, we have a power stack. So power stack, it's a generalized power stack. So any converter, any power converter can be built, either could be a buck converter or boost converter, or modifications in DC-DC converter topologies, or modification in AC-DC converters or DC-AC converters is possible with that system. Then we have real-time rapid control controllers. So wherein if you want to develop any control algorithm, whether it could be MPPT tracking for a solar applications or for wind applications, or whether it could be a voltage regulation applications, yes, we can do with that FPGA based hardware. And similarly, we have like emulators like solar and wind emulators to emulate the actual solar system as well as wind system. Which are mainly used for testing the control algorithms. We have high precision AC-DC power supplies. We have electronic loads. We have three-phase power quality analysis as well as insulation testing equipment. So, and then we have some other tools like we have MATLAB software with us, and then we have Altair PSIM software also. We have like electrical vehicle charging setup is there to test the BMS, like battery management systems. And then we have some small range PCB CNC etching machine, so that we can readily do the PCB in case if any MSCs has approached us. So this is like one schematic of phase 1 system. So we have, as I told, like we have one setup like microgrid setup, and one setup is a solar grid setup to test the algorithms actually. And other infrastructure is like shown here, like some 2.5 kilowatt plant of solar system as well as wind systems. We have some lead acid batteries, then we have rapid real-time controllers, and then some microgrid setups, then electronic loads, and then some power converter stacks. So and wind emulator stacks. So and coming to testing equipment, like this is one some testing equipment, insulation testing. So for testing the wires as well as the power quality analyzer. If any inverter, if they come in the market, then total harmonic distortion of the inverter as well as efficiency of the inverter plays an important role. So this testing equipment will help us to do that activities. And coming to the incubation, like we also support in incubating the new startups in the comes in the area of renewable energy, and then we are also extended for electrical vehicle area or automobiles area. And then we are working with the institute incubation cell, and then we are also having good links with the like legal advisors and angel investors. So some of the startups incubated in CRTDH is one is NDIP Connect. They are into giving the services in the areas of electrical vehicles and 5G communication. And another startup incubated in our CRTDH is Pranitra Research Limited. They are actually a service-based company, and then they give service for spraying the pests for the farmers. And then one is Radhanu Technologies. They are into IoT, creating IoT solutions as well as energy management. So another area which we are looking is skill development. So we give hands-on training in the state of art of renewable systems, and also like because we are also incubating, we are also giving managerial training programs for the for the startups. And then we also giving training program so related to industry standards and then policy and certificates. So which is very important for them to convert into to go in a big scale. So like other skill development components, so if you look at, like we will be talking about the mathematical modeling of renewable systems, then designing and sizing of like how what range or what size should be selected, like PV size and then like wind size. Then similarly control algorithms and the power management schemes we do. And then we hands-on sessions like simulation in MATLAB is also there in skill development component. Then forecasting techniques and then rapid prototyping like hands-on, and edge devices role and importance in renewable systems. So like we had some meetings held, like we interacted with MSME Technology Center Visakhapatnam, and then MSME Development Fabrication Office Hyderabad, and MSME Development Facilitation Office Visakhapatnam, MSME Hyderabad, and Directors of Industries Government of Andhrapradesh, and then we have interaction with MSME Incubation Center at different colleges also. And then we took like Adam Tech is one MSME has approached to develop DC-DC converter technologies. Then Nova Auro blockchain technologies, they have come us to develop power converters for creation like data centers. Especially they want to build renewable assisted power supply. Then we have Entupul Technologies. They was developing a hybrid energy generation. So with the small scale solar and wind. Then Minan Labs, they want to like again they are also related to data analytics, but they want energy management from CRTDH. Then Agraian Electric Technologies, they ask us to do like in like EV battery management system. Then Vyomic Innovations, they are into UAVs. And then Pranatra Research, of course, they are incubated companies. They they're looking like in the areas of wireless power transfer. So these are some services offering to MSCs in a nutshell. Like one is like dispatching or throwing the know-how in terms of delivering first-hand R&D solutions. Then developing some simulation tools as well as repositories and design tools in the areas of renewables. And then decentralization power generation. Then increasing the, as I told, like the technologies related to increasing the penetration of renewable energy systems, both PV as well as wind. Then like optimal sizing, optimal control. Then we also helps to improve the reliability by developing loss models of different inverter systems. Then support MSCs in like power quality enhancement, so both in off-grid as well as on-grid. Then as I told, like repository collection in the areas of renewable sectors, so that it is made available to the MSCs for quick adoption of recent technologies. Then incubations of startup and MSCs. So this was the major technologies developed as on now. So one is dependency of like we minimize the dependency of PV side sensors, and then the control for MPPT is implemented using grid side and voltage sensors, which are generally employed for grid synchronization. With the same, we are trying to achieve the maximum power point. Another is some requirements are there when we talk about vehicle to grid and grid to vehicle concepts. That is development of a impactful bidirectional converter. So that is one work we have implemented. So these are like you can see the figures here. So the circuits of that. And so as I told, like myself, Dr. Shankar and Dr. V. Sandeep, we are the program managers for this. And then we have a stall in stall number 22. So wherein you can navigate our center, you can look into like like our center. So just for your convenience, I have posted here. This is our slide. This is our DSIR looks. Like that online portal will looks like here we can see that looking for collaborations. If some problem is there, like you can always like register, you can navigate through, click here for registration, then there will be a Google form will appears. So you can look into like you can address, basically you can give some responses like what is the problem you are facing, and then how can like we give a solutions. And then like even if they require some equipment for testing also, we so that form will help us to navigate. So with this, I would like to thank everyone and especially Dr. Chinmay for arranging this event in a beautiful manner, and the organizers of the CRTDH delegates. So thank you.
Thank you, Dr. Shankar. This is the last presentation of this session. This is also a very new CRTDH, just came up 1.5 or 1 year, 2-3 months back. They have done quite remarkable work, and I saw that they have incubated 3 companies, which is quite encouraging. In fact, electronics and renewable energy is one sector which is of great importance for our country. They are not into chip development or those areas, which of course is the sunrise sector, but they are working in other areas of electronics, which is also equally important. We have been able to reach the southern part of Andhra Pradesh through their institution and establish one CRTDH there, which I think would be helpful to not only that area, the companies situated in that area, but of course to the entire country. And as he said, that they have already developed the website for CRTDH. They have given the web address, and in addition to that, Professor Chinmay Ghorai, he presented about the network portal what we have now started. So you can start surfing that also, and I request all the PIs to just provide all the information what Professor Chinmay Ghorai wants and he needs to populate the information and data into the portal. So please cooperate with him. Please send all the information. Thank you very much, Dr. Sandeep.